Okay, so this first problem, we're rewriting this equation in vertex form. So you got to know what vertex form looks like. So that's going to look like this. Um, you'll be able to tell what the vertex is by looking at it. Okay. So it's tempting. We're gonna complete the square to do this. So it's tempting to divide the whole equation by 2. But if you do that, then you'd have f of x over 2 on the left side of the equation, and that would be a mess. So let's not do that. Don't divide the whole equation by 2. What we want to do is first move the 3 out of the way. Okay, so that means I'm going to subtract 3 from both sides of the equation. Okay, and I am going to look for a mystery number, but before I do that, now I want to factor out a 2 on the left side of the equation because I still want to deal with that coefficient in front of the x. So if I factor that out, I'd have this. And then now I'm going to look for the mystery number in here. Okay? So on the left side of the equation, I want to also add in my mystery number, but here's the thing. This mystery number has a 2 factored out of it. Okay? So on the left side, I don't want to just write plus the box, plus the mystery number. I want to write 2 times the mystery number to account for that, because then I'm really adding the same thing to both sides. I'm adding 2 times whatever number to both sides. Okay? All right, so now it's time to find the mystery number. So I'm using b over 2 squared to do that. B here is going to be -4. It's tempting to use -8, but I'm using it in this trinomial. So -4 over 2 squared. So that's going to be -2 squared, which is +4. Okay, so I put the 4 in on both sides then. All right. So I'm going to start cleaning this up on the left side. -3 plus 8 would be +5. Okay. On the right side, I want to factor the trinomial. Okay. So you can use a diamond problem to do that. It's going to end up x equals x minus -2 times x minus 2 times x minus 2. So it's going to be a perfect square. And that was the point of getting the mystery number there, right? Because I created a perfect square trinomial here that would factor like that, okay? Now looking at this, it's almost in this format. All I have to do is move the 5 back over. So I'm going to subtract 5, and now I can see there's my vertex form. If someone asked me for the vertex, it would be 2, -5, right? It'd be really easy to see that, okay? There's an alternate way to do this, which would be to find the vertex using the axis of symmetry and then plugging your x value in to get the y value. And then in this format, you know the a is going to be 2. So that's another way you could write the vertex form like that, okay? But I'm going to use this completing the square method, so let's try it again over here. So first thing I want to do is move the 128 over, so I'll subtract that from both sides. Okay, then I'm going to factor out the 5 on the right side. I'm going to leave myself some space on the left because I know I'm going to need it. Okay, and now I'm working on getting a perfect square trinomial here, so I'm going to be looking for the mystery number over there. Okay. On the left side, I'd had f of x minus 128. And now to balance this out, I want to add 5 times the mystery number to the left side as well. Okay? All right. So then it's time for my mystery number. So I'm doing b over 2 squared. B then is -10, not -50. Remember to use this as your b. That's the quantity -5 squared. So -5 times itself is positive 25. The mystery number is always going to be positive because you're always squaring something to get it. Okay. So then I've got 25 on both sides there. Okay. So let's see. 5 times 25, 5 quarters is $1.25. Okay, and then I'll factor this trinomial. It's always going to be something squared. So I'm thinking, oh, 5 times 5 is 25, but that won't work out to get you the -10 in the middle. So it's going to have to be x minus 5 times itself. Okay. Just finish that arithmetic on the left, and now I want to isolate the f of x, so I'll add 3 back over, move the 3 back over to the other side, and here is vertex form. Okay. All right, so that was kind of leftover from 3-3. Let's get into the quadratic formula. So first off, finding zeros, this is just the standard form equation. If I want to find the zeros of this equation, I want to find what x values would give a y value of 0. So I'm just plugging in 0 for y. Okay. So let's say that I was going to take this and solve it for x. If I wanted to isolate x, it's a little tricky because I've got 2 different x's in 2 different places. Okay. What you'd have to do is complete the square. And if you did that, I'm not going to run through that, but if you completed the square from this to solve for x, this is where that would lead you, right? So you see this is made up of a's, b's, and c's, just like this is. This is just this rearranged so that x is isolated, okay? And hey, that is the quadratic formula. That might look familiar to you. Okay, so this is going to be useful because with any quadratic equation, you can solve for x just if you know what a, b, and c are, okay? Okay, so let's take a look at the quadratic formula in action on the next page. So here's the formula again at the top of the next page. And so solve with the quadratic formula. This is a quadratic equation, so hey, I can plug everything into this format. So you got to make sure you know what a, b, and c are. This is in standard form. That's nice for picking out a, b, and c. A is the coefficient of the x squared term. B is going to be the coefficient of the x term, and c is the standalone there. Okay, it's the constant. Okay, so let's start plugging things in. When I do this, I like to first just rewrite the formula with blank parentheses. So you want to use parentheses when you're substituting. If you don't, it will probably lead you to some mistakes. So I'm not even looking at a, b, and c. I'm just rewriting the formula with blanks. Okay, so first 2 slots are b's, so those are going to be the 10s. Okay, these 2 slots are a's, so those will both be 1 for this problem, and the c goes right there. Okay, so from here on out, it's just a PEMDAS problem. Okay. So I'm just going to start simplifying this. Looks like a giant mess, but it actually cleans up pretty quickly. Okay, so I'm going to start with squaring under the radical there. 10 squared is 100. Okay, and I find actually that the most mistakes get made in this area just because we're multiplying 3 things together. Okay, so this one is not too bad because I've got -4 times 2. But I just find people often mess up signs in this part. So if it's helpful, pull those 3 numbers out, whatever they are, multiply them together, and then put them back in. Okay. And then this is all over 2. Another thing I see people do is they'll just put they'll just divide by 2 under the radical. So they'll just write this as -10 plus or minus a fraction. Okay. But the 2 is the whole thing is divided by 2. Okay. So I've got x equals -10 plus or minus root 92 all over 2. Okay, and then I still want to put this in simple radical form, so I want to break apart the 92 and see if there's any twins in there. Okay, and if you start I can see it's an even number, so you could play around with it with a calculator. Right, so if I had 92 on a calculator, if I divided that by 2, it's 46, which is another even number. So I can divide by 2 again, so now I've got 2 times 2 times 23. Right, 23 is a prime number, so I can't do anything with that, but hey, I found some twins. So one of those will get out, the other one will disappear. So now I've got -10 plus or minus 2 root 23 all over 2. Okay, now looking at this, I can still simplify this a little more. I'm looking at all 3 terms. You could split this. You could split this into 2 different fractions if you wanted to and start simplifying. But you can also think, well, hey, these are all even. There's something that goes into all of these, right? So that means I can reduce. But you have to be able to reduce all 3 terms. So since those are all even, I can divide them all by 2. And so then I get -5 plus or minus root 23 over 1. And dividing by 1, nothing happens, right? Maybe it's clearer just to show you. I can split it like so. And then reduce each part. So I get -5 plus or minus root 23. Because those 2's will cancel there. And there is my solution. Okay? And we want solutions typically in simple radical form, not as decimals. Okay? All right. So let's try another one here. So this again is in standard form. If it's not, put your equation in standard form first. So A is 2, B is -1, C is 2. So you could pause the video and try it out if you like. Rewriting the formula with blank parentheses. Okay. B's go in the first 2 slots. A's go in these 2. And C just goes in that 1 slot. Okay, and then I'll start simplifying. So, you know what I was talking about before? 4 times 2 times 2. That would be 8 times 2. That's 16, but I'm still subtracting that, right? And this is all over 4, okay? Okay, so I got it down to this. Now, in the olden days, we would have said no solution, but now we've talked about imaginary numbers, so we can deal with negatives under the radical, okay? So 15 is 3 times 5. There's no twins there, but I can think of that as 1 plus or minus square root of -1 times the square root of 15, right? Which means, hey, this is I. I wouldn't usually normally write this step in there. When you have a negative, it's just going to become an I on the outside of the radical. And there we go. Okay. Okay, next I want to look at let me get the next page up. Want to look at a little guide for solving quadratics, because we've covered quite a few ways that you can solve quadratic equations now. Okay, so this is just some advice. I would usually solve using square roots, taking the square root of both sides. I would do that when b equals 0. So b is the x term, so that would mean there'd only be an x squared term. So something like this, if I had x squared equals 25, Well, then I just take the square roots of both sides. Square roots of both sides, right? So x would equal plus or minus 5. That's the positive and negative root of 25. Okay, so that's an example. Okay, factoring. I would try to use this when you have relatively small integer values for a, b, and c. Okay, so if I was dealing with fractions or decimals or large numbers, I probably wouldn't try factoring. But if I had smaller numbers that are nice round numbers, then I would try to use that. Okay. Um, if the equation is not factorable, then we only have two options, and that's completing the square or the quadratic formula. Okay, so I like to use completing the square when b is even. I think completing the square is a little bit quicker, but only if the b is even, because when we're looking for the mystery number, it's b divided by 2 squared, right? So we're going to be dividing b by 2, and that just works nicer when b is even. If it's odd, then we'll get some fractions in there, which isn't the end of the world, but okay. I would use the quadratic formula when b is odd, or when a, b, and c are large numbers. So I'm going to say if they're large, or fractions or decimals. It just becomes too much of a hassle to do it completing the square. You certainly can, but it's easier when you're dealing with those situations to use the quadratic formula. All right, so let's try some word problems. One leg of a right triangle is 5 units longer than the other leg. Let's draw a picture here. Got a right triangle. Okay, the hypotenuse is root 97. So the hypotenuse is across from the right angle. It's the longest side, right? So one of the legs is 5 units longer than the other leg. So if this is my shorter one, if that's x, the other one's going to be x plus 5. Okay? Let's find the length of the short leg. So here's my short leg. So I'm solving for x here in my picture. Okay? So what I want to do is use the quadratic formula. Not the, the quadratic formula. The Pythagorean theorem, not the quadratic formula. Oh man, I'm not in the geometry zone right now. But that's my Pythagorean theorem, right? These are the legs. This is the hypotenuse. So one of my legs is x. The other one is going to be x plus 5. And my hypotenuse is square root of 97. Okay. So let's start cleaning this up. Tempting to just say this is x squared plus 25, but it's not. You got to remember this is x plus 5 times itself, so we're going to have to FOIL that out, okay? On the right side, this works out nicely because square root of 97 squared is just 97, okay? But over here, we want to FOIL, first, outer, inner, last. First, x times x, outer, x times 5, inner, 5 times x, last, 5 times 5. Going to add together all those bits, and that was just for this part, right? So I still have the x squared out here, and it's still equal to 97, okay? And then let's start combining like terms. So x squared plus x squared is 2x squared. 5x plus 5x is 10x. Okay, so now I've got this written as a quadratic equation, and I have to decide what my strategy is going to be. The first thing I would do is set it equal to 0. So that's what I'm doing here. When we subtract 97, I'm going to get negative 72 over there. Okay. And now looking at this, so I could try to factor this here. But also, since this is an equation that's set equal to 0, rather than factoring out the 2, I'm just going to divide the whole equation by 2. 0 divided by 2 is 0, so this is going to work out nicely. And those are all even numbers as well. So this just makes it easier to deal with. And now I'm looking at this, and I'm thinking I might be able to factor that. I might not be able to. If it's a dead end, then I'll have to do quadratic formula or complete the square. But why not take a crack at it? Okay, so I'm looking for two numbers that add to 5. The same two numbers multiply to negative 36. 6 and 6 won't work. 1 and 36 won't work. 12 and 3 won't work. How about 4 and 9? That will work if the 4 is negative and the 9 is positive. So then I've got x minus 4, x plus 9. This is all equal to 0. So I'm still going to solve this, right? So if x minus 4 equals 0, then x equals 4. If x plus 9 equals 0, x equals negative 9. And now I'm thinking, well, would it make sense? Would both those answers make sense for the sides of a triangle? I can't have a negative side to a triangle because it's a distance. So I'm going to throw out this because it doesn't make sense in the problem. And then there's my short leg. Okay. Okay, on to another application problem on the next page. So next up, we've got the product of two consecutive even integers is 1,368. Find them both. Okay, so you got to know what consecutive means. Let me focus my camera here. So consecutive means they're going to be in a row. 7, 8, and 9 are consecutive integers. So consecutive even integers would be 8 and 10 or whatever, right? So this means in a row. Okay, so all right, so let's call our first integer a. Okay, and the product means we're multiplying. So the product is 1368. So when I multiply my two numbers together, it gets 1368. Now you could do a trial and error thing and it wouldn't take you that long to find these, but let's do this algebraically, okay? I don't know the value of a. Let's just call it x. Okay, but if I compare a to b, let's say x was 10. Well, then I know b would be 12, right? It's going to be 2 more than that because the next even integer would be 2 more than that. So whatever this integer is, the next one is going to be 2 more than the first one, okay? And now I've actually got an equation that I can solve. So if I can solve this for x, then I'll know what a is, and then I just add 2 to that to get b, okay? All right, so let's start solving this. I'm going to distribute the x. So x squared plus 2x equals 1368. Okay, I'm going to set this equal to 0 next. And then I've got a decision to make about how to proceed. You could actually factor this, but it would be kind of a pain because I've got such a large number here if I was trying to do a diamond problem or something. I could do quadratic formula. You could also complete the square. I'm going to actually complete the square because I've got an even b integer, but quadratic formula wouldn't be a bad choice either. Okay, so I'm going to look for the mystery number, which is not negative 1368. So I'm going to move that back actually to where it was. I'm going to add 1368 back over there. I'll be adding my mystery number to both sides. Okay, so let's find that mystery number. I'm taking half of b and squaring it. b is 2. So 1 squared is going to equal 1. So my mystery number is 1. Okay? And then this should factor into something times itself. And it does. It's going to be x plus 1 times x plus 1, also known as x plus 1 squared, the quantity x plus 1 squared. And that comes out to 1369 over there. Okay? Now I'm going to take the square root of both sides, and don't forget, positive and negative root of 1369. Okay? And then let's subtract 1 from both sides. Oops, negative 1 plus or minus 1369. So I put the negative 1 in front of the plus or minus symbol. Now, you could start to try to put this in simple radical form. But since I know I'm looking for integers, I'm not going to have any decimals or fractions here. I'm not going to have any square roots in my final answer. So I'm pretty sure that this is a perfect square. So I just put it into a calculator, and it comes out that the square root of 1369 is exactly 37. Okay. Now I don't want to leave my answer like this though, because that's a weird way to say what two integers are. Okay. So I'd want to actually simplify it further. Because I can sort that out, right? That's one of my answers. And the other answer, I'm going to subtract 37. So then I'm going to get 30, this would be 36. And then this would be negative 38. Okay. So let's see. I've got two different values that A could be. All right. So A, if A is 36, okay. Well, B is going to be 2 more than that. So B would be 38. Okay. So that's one possible solution. But I got another X value. And integers can be negative, right? So X could be negative 38. And then B would be 2 more than that, which would be negative 36. And you could try them both out. 36 times 38 would be 1368, but so would negative 38 times negative 36, right? So you got two different possibilities there, okay? All right, on to this next problem. We've got a rectangular pool that's 10 by 20 feet, and then there's a walkway surrounding the pool, okay? And both the pool and the walkway are rectangles. The area of the larger rectangle is 416 square feet, and we want to know how wide the walkway is. Let's assume the walkway is the same width all the way around the pool, okay? So I would really recommend drawing a diagram on problems like this, okay? So here's my rectangular pool. I'm told that this is 10 by 20 feet, so hey, I'll make the smaller side 10. I'm putting those numbers on the inside because I'm going to put some stuff around the outside, okay? So then we've got a walkway around this. To make my larger rectangle, okay? So the area of the larger rectangle, we're told, is going to be 416 square feet, okay? All right, so our goal here is to find the width of the walkway. So here's how we can do this. If I can write some expressions for the width of the larger rectangle and the height of the larger rectangle, then I'll be in business, okay? So ultimately what I'm trying to find is the width of the sidewalk. So I'm going to put X right there. But then I've also got X over here, okay? So now when I'm looking at the width of the whole rectangle, I'd have X plus 20 plus X, right? Going all the way across. So we can simplify that. That's going to be 2X plus 20. Okay, and we can do the same kind of thing with the height. So if I look at this, this would also be X, right? It's the same width. I've got X up there. So now I can write an expression for the height. It's going to be X plus X, which is 2X, plus 10. So this is going to be 2X plus 10, going from there to there, okay? The mistake that I see a lot of times, people will just say, oh, this is going to be 10 plus X, because I'm taking the pool width plus the sidewalk width, but you got to remember there's a sidewalk on both sides. Same thing here. It's not just 20 plus X, it's 20 plus 2X, because you got the sidewalk on both sides. Okay? So now I can think about the area of a rectangle. So I know my area formula is going to just be base times height, right? And hey, I know the area is 416. And now I've got the base is the quantity 2X plus 20. And the height is the quantity 2X plus 10. Okay, and I should be able to solve this for X. So I'm going to start by foiling the product of, I've got two binomials, so let's FOIL them together. So first, 2X times 2X is 4X squared. Outer, 2X times 10 is 20X. Inner, 20 times 2X would be 40X. And last, 20 times 10 would be 200. I'll add all those bits together. Okay, now I want to set it equal to 0, so I'm going to subtract 416 from both sides. Okay, and now I've got a decision to make again about how I want to try to solve this. So I'm looking at that, and the first thing I'm thinking is, well, these are all even numbers, so I could definitely divide this whole equation by 2. And in fact, I might be able to divide it by 4. I do know that 4 goes into 60, and we could try with a calculator. It turns out it does go into 216 as well. So it's just going to make it easier to deal. You could factor out a 4. And nothing wrong with that at all. But I could also just, since I have two sides of the equation, I can just divide the whole equation by 4. And that'll make it a little bit easier to deal with this equation. Yeah, and oops. So all of a sudden this is looking a lot easier to deal with. I think I'm going to try to factor this because I've got some relatively small numbers here. So maybe it's factorable, maybe it isn't, but let's see what we can do. I'm going to use a diamond problem here, so I've got 15 and negative 54. Okay, so I'm thinking of ways to multiply to get negative 54. I'm thinking my times tables, and 54, well, no, it's not going to be on my normal times tables, but you know, you can just start playing around with it. It's an even number, so I know 54 you can divide by 2 to get 27. So I could use a 2 and a 27, but even if one of those is negative, there's no way I'm going to get to 15. So that's kind of that's a dead end. But 27, I know 3 goes into 27, so does 9. So I could try dividing 54 by 9, and or 3. So you know, 6 times 9 is actually, I don't know why I didn't try that one for us. So that's the times table one that I was thinking of. So that is promising, right? Because I'm thinking 6 and 9 add up to 15. But one of them has to be positive and one has to be negative. So actually neither of those works. So let's try 3. We haven't tried 3 yet, and I know 3 goes into 6 and 9, so it should also go into 54. So if I take 54 and divide by 3, I get 3 and 18. And wait a second, I can do something with this. If the 3 is negative and the 18 is positive, okay? So that tells me what goes in the back of my parentheses here. So I factor this. I haven't solved the problem yet, but now I know one of these factors has to equal 0. So if x minus 3 equals 0, x equals 3. And if x plus 18 equals 0, then x equals negative 18, okay? Now, doesn't it make sense for me to have a sidewalk that is negative 18 feet wide, or a walkway, I mean. So just going to throw that one out. All right. So this one is the one I want to use, and I want to put the units on there because I want to show how. Is it 3 miles? Is it 3 inches? Nope, it's 3 feet. Right. That's what my units are in. Okay. All right. Okay. Next page, we're going to talk about the discriminant. So here's the quadratic formula. And the part that is underneath the radical, right here, this is called the radicand, but in this part in particular is called the discriminant. Okay, so it equals b squared minus 4ac because that's what comes under the radical. Okay, all right, so here, this is annoying me that this doesn't have the arrows, so I'm going to just add those in to these parabolas. Okay, so there's something that we can, there's a little test we can do to see what types of solutions we're going to have to equations, okay, or how many zeros we're going to have. So if the discriminant comes out positive, let's say this whole thing came out to positive 9. Well, then I have the square root of 9. So I'd be adding 3, and I'd be subtracting 3 from whatever the negative b is, right? So that's going to give me 2 solutions when the whole discriminant is positive, okay? And the solutions are indicated by the x-intercepts there, okay? When we're dealing with an equation like this, right down here. Okay, so so this is going to have 2 real solutions. And that's always going to happen like that when the discriminant is positive. If the discriminant is 0, then your parabola is going to touch the x-axis in exactly one place, and you'll have one real solution. Okay, and that kind of makes sense if you think about it up here, because you'd be adding and subtracting the square root of 0. Well, the square root of 0 is 0, so you'd be adding and subtracting 0 to something, and that's going to just get you one solution, because adding and subtracting 0 does the same thing, right? If this all comes out negative, well, then we're going to have actually an imaginary solution, okay? And so say this came out to -7, then we'd have I root 7 for this piece, okay? So we would be adding I root 7 and we'd be subtracting it, so we'd actually get two imaginary solutions. That would be a parabola that doesn't cross the x-axis at all, but there still are two imaginary solutions. Okay, so that means that we can take an equation and do a little test using the discriminant to see how many solutions we're going to have and what type. Okay, so on this next problem, it says find the discriminant. Well, the discriminant is b squared minus 4ac. Okay, so I'm just going to plug in those pieces. B here is -3, a is 2, and c is going to be -4. So it needs to be in standard form to see the a, b, and c, right? So then I just start simplifying. Okay, and then this part's where I see a lot of mistakes get made. So if you want to think about this separately, I've got -4 times 2 times -4. Okay, so that gives me -8 times -4. That means I've got +32. Okay, see, a lot of times people mess up the signs when we're multiplying three things together like that. So this is going to, my discriminant value then is going to be 41. Okay, all right. So how many solutions do I have? Well, it doesn't matter actually what the value exactly is of the discriminant. It just matters if it's positive, negative, or 0. So this one is positive. So hey, it's going to have two real solutions because I'll be adding and subtracting the square root of 41 if I did the quadratic formula. Okay, so it has two real solutions. You know, so you could go through with the whole quadratic formula or solving this equation in a different way and just see how many solutions you get. But this is a much quicker little test to just find how many solutions you got. Okay, so let's try another here. You can pause it if you like. I'm going to use b squared minus 4ac to find the actual value of this. B is 4, A is -3, and C is -2. Okay, so I've got 16. -4 times -3 would be 12, right? So that piece is going to be 12. Okay, and again, if you need to pull this part out and solve it separately, go ahead and do that. So that piece comes out to -24, right? And then so I've got -8 for the value of my discriminant. And hey, that's a negative number, so that means this parabola is not going to cross the x-axis. It means it's going to have two imaginary solutions. Okay, and that is it for the section. See you next time.